In this video, I'm going to show how to spot and develop a TLC plate, and I'll be using this solution which has two different kinds of solids, two different compounds dissolved in methylene chloride. So you should grab a TLC plate from the container given to you from the stockroom, and the first thing you should do is mark where you'll be spotting the TLC plate with a pencil. And make sure to use a pencil and not a pen because the ink can mess with the separation. Using that pencil, you should draw a line just a few centimeters above one side of the TLC plate so that when the TLC plate is added into the developing solvent, the solvent remains below that line, and that way it won't just instantly dissolve the solid compound that you placed onto the silica gel. And then you can also draw a small line to mark exactly where you will be spotting the TLC plate. All of these lines and marks should be done by pressing the pencil lightly on the silica gel because you don't want to break the silica gel off of the tinfoil sheet that it's been adhered to. Now, to spot the TLC plate, we want something with a small surface area that will only deposit a small amount of that solution onto the silica gel at a time. And oftentimes using a pasture pipette or even a capillary tube will create a spot that is too large to see a properly developed TLC plate. But we can modify a pasture pipette by extending it to decrease its surface area. To do that, you can use the Bunsen burner found in one of the hoods, and you can turn that on by using a match or a lighter, and on the side of the hood there's a valve labeled as lab gas. As you turn that slowly, the Bunsen burner will be ignited. Now you're ready to heat up the pipette to extend it. So in that same hood there should be a box containing longer pasture pipettes, which will be used because they're easier to hold over the flame without burning yourself. What you should do is hold the pipette by both ends and place the thinner portion above the flame, spinning one end with your fingers so that it heats evenly. As the glass heats up and begins to bend, you should remove it from the flame and quickly pull the two ends apart, extending the heated portion of the glass. That thinner portion can be seen here, and that should create a nice small spot on the TLC plate. You can then break that extended portion in half using a spatula, making sure to clean up any broken glass that would have come off. As you dip that pipette into the solution, a small amount will be drawn up through capillary action, and as you press the end of that pipette onto the TLC plate, the solution will be spotted onto it, and pretty quickly the solvent will evaporate, leaving the solid product adhered to the silica gel. Now, let's say that you wanted to make a second spot with a separate solution, but didn't want to contaminate it by using the same pipette that was used to make the first spot. Instead of going over to the Bunsen burner to make a new extended pipette every single time you want to make a new spot, what you can do is remove the remaining liquid in the pipette by pressing it against a paper towel until all the solution inside is removed. And then you can clean that pasture pipette by dipping it in some methylene chloride, which will draw some solvent up inside, and can be removed in the same way by pressing it against a paper towel a couple of times. This should be done a total of 3 times to ensure that any of the product from the previous solution is completely removed from the pipette before dipping it into a second solution. Once you're done with that though, you'll have a clean pipette that can be used to make a second spot, or you can even follow the same procedure to make multiple spots with multiple solutions. To develop the TLC plate, I'm going to be using methylene chloride as the mobile phase, but you should follow what your procedure says because that solvent can vary depending on the polarity of the compounds that you're trying to analyze. You can add the solvent to a WMSC bottle using a pasture pipette, and that should be added just until the bottom of the container is lined with that solvent. You don't want to add too much because when you add the TLC plate, you want the solvent to remain below the line that you marked and where you spotted the TLC plate with the product. Then, using your forceps rather than your fingers, you can gently place the TLC plate into the bottle, leaning it back against the side of the container. You'll notice the solvent starting to move up the silica gel, so you'll want to cap the bottle in order to keep the solvent from evaporating as it moves up the TLC plate. I've sped this video up quite a bit, but after a few minutes, eventually the solvent will move all the way up the TLC plate, but you want to stop it before it reaches the top. Once the solvent is about the same distance from the top of the TLC plate as the line that you marked with pencil is from the bottom, you can remove the TLC plate using your forceps, and with a pencil, mark exactly how far the solvent traveled on the silica gel. This should be done right away because the solvent can evaporate pretty quickly. Now, initially, looking at the TLC plate, you're not going to see anything because the compounds that we placed on there are colorless. So unless the compounds that you're analyzing are colored, you're not going to be able to see where they ended up unless you use a UV light. This instrument is found in the instrument room and has a UV light source. So as you turn it on and place it over your TLC plate, you'll be able to see exactly where those compounds ended up. And this works because there are absorbents in the silica gel that contain a fluorescent indicator, so when you illuminate it with a UV light, the plate fluoresces visible light. But the separated compounds appear as dark spots on the fluorescent field because the substances forming those spots usually quench the fluorescence of the absorbent, and that way we can see them pretty well. What you should do at this point is mark those dark spots with a pencil so that when the UV light is removed, you can still see where the compounds ended up. And from here, you can calculate the RF values for each of the compounds on the TLC plate.